Well, welcome back, geometry students. So here we are with geometry's 9.3 lesson, similar right triangles. And so we're going to be looking at in this lesson are how some right triangles are going to be similar, of course. We're also going to be looking at something called geometric means, and we'll see what that's all about here in just a little bit. And also we need to remember about altitudes. You can see that's here in this essential question, how are altitudes and geometric means related? So altitudes, again, we'll look at what those are. We saw those in previous chapters. But first, let's go ahead and do a little cartoon time, a little Far Side cartoon. So here's three old men sitting on a porch. The first guy says, "Uh-oh, rain squalls are coming. My knee's acting up." And he gets all big. And the middle guy says, "I'd say more like a blizzard, judging by my hand here." And then the last guy says, "Well, something's happening. There goes my head." Old guys and their ailments. Alright, well, let's go on to looking at our similar right triangles. So first of all, we're going to look at this theorem of right triangle similarity. And basically what this is saying is if we were to draw an altitude, so an altitude, what is an altitude again? An altitude is a line that goes from like basically the right angle. It's going to be from the right angle. It could be from any triangle, but we're going to use it from the right triangle of this one here. So we're going to draw an altitude from the right angle of this triangle to the opposite side, which would be the hypotenuse. An altitude has always got to be perpendicular to that opposite side of the angle. And so that's what this is here. So if an altitude is drawn to the hypotenuse of a right triangle, then the two triangles are formed are similar to the original triangle and to each other. So basically, by drawing this altitude here from C to D, it forms two more right triangles, because here's another right angle on this side and this side. So we have another right triangle here, which we are now kind of broken apart into the red one, and we have a smaller one here in the blue one. And so we can write a similarity statement, and let me just go through how we would write this similarity statement. If you look at the blue one here, it says CBD. So you gotta look where CBD is. So C is up here. So you're basically going from C to B, which is the hypotenuse side, and then B to D, which is the short leg. So that means if we're doing that on this blue triangle, we're going to have to do that on all the other triangles so that our similarity statement all matches up. So if we look at the red one then, and we're going to draw it from, or first going to go from the hypotenuse, so A to C, and then from C to D is the short side. That's why we do not say CAD. That would be doing a hypotenuse, but then it would do the long side. Now, the way they did it in the blue one here is they started with hypotenuse, then short side. So we got to do the same thing, hypotenuse, then short side. So C, or AC, then D. And back over here on this original one, we would start with hypotenuse, which is A to B, and then short side B to C. And so you can see it's just A, B, C on that one. So that's how we want to make sure we're saying them in the same way each time. Alright, so let's go ahead and practice this on the extra practice, which is on page 256. So 1 and 2 just identify the similar triangles. We just need to write a similarity statement. So here's our altitude right here from J to K on this one. And so you can see you have obviously the one big triangle, then you have these other two smaller ones. And so we want to start with writing a similarity statement. You can really start with any triangle you want to. So you just pick a triangle and you just start doing the letters in a certain order. You just got to make sure you do the same order on all the triangles. So I'm going to start it with this one here. Oops, let's bring it back to here. So let's start with HJK. So HJ then K. So I'm starting it with this triangle here on this side, going from HJ to K. So let's see what that would be. It's a hypotenuse right here, and it's going to be a leg. Now these legs look like they're about the same almost, so there's really not one that's much bigger than the other. So HJK is on that one. So if I do the other triangle on this side, I got to do the hypotenuse IJ to K. I would do that one. That would be in the same way, IJK. And then for the larger one, the hypotenuse is here, H to I. So I'd probably do HI and then to J. So Hij would be that one. So there's our similarity statement then, identifying which triangles they are similar. They're all similar to each other, and so you just got to make sure you write them out properly. On number 2, here we just got to figure out which one we want to start with. I decided to start with M, N, and P. So that would be the one here at the bottom. So M to N, and then going to P. So that would be the hypotenuse again here, and then a leg. And so the next one we'll do is MOP. So MO is a hypotenuse, and then to the leg this way to P. And then we do the biggest one. So the hypotenuse of the biggest one is N to O. So we could just do it like that. NO and then to M. So NO and then back to M gives us that same configuration of the letters. Just got to make sure you're doing the right thing there with configuration. Okay, so we have the next topic here is the geometric mean on the bottom of page 254. So go over to that page. At the very bottom there, you'll see the core concept. And it says the geometric mean, this is what it means, this is the definition there. You can highlight that. It's the geometric mean of two positive numbers, A and B. So A and B are two numbers. Is the positive number x that satisfies this proportion, where you have a number over x equals x over the other number. And then what we could do with that, we could cross multiply. So we could do x times x is x squared, and a times b is ab. So we can make it like this, where you see x squared equals ab. And then to get rid of the square, we could take the square root of both sides to make it even simpler here, and x is now equal to the square root of ab. And so this is what I wrote over here, and you want to write this down maybe next to that. I'd circle this part. That's like the main part if you can just remember this. This is how you find the geometric mean. It is basically the square root of the two numbers multiplying each other. So whatever numbers we have, here's one example, and go ahead and write this down underneath this core concept here. You can just write the numbers 24 and 48. Those are the two numbers. And so all we have to do really here is just multiply those two numbers and then take the square root of it. So here's what they're going to show us here. There's the x squared equals the ab. They started us right here. They did a times 24 times 48 there. And so they figured that out. Again, they're going to take the square root of that. So there it is. And I usually don't really write this part down. I really just kind of usually start right here, writing down the square root of 24 times 48. And what that equals there. So we can see we can factor that. So you can see they factored out for 48, they broke that apart to 24 times 2. So there's two 24s in there. So if there's two 24s, that's like 24 squared, and that would then come out of the radical sign. So 24 is on the outside, and then square root of 2 is still underneath. So they left this one as a radical. They simplified the radical. They could have multiplied these two together. They would have got a pretty big number, though, and that would have been probably hard to figure out how to get down to this simplified radical. It was probably easier for them to see, well, I have another 24 in here with 48. If I just do 24 times 2, well, there's two 24s, and that means 24 can come out, because the square root of that would then just be the 24. And then 2 would still be underneath. All right, so let's try a couple of these on our own in the extra practice. Okay, so back at the extra practice on page 256. So here's our two numbers for this one. We want to find the geometric mean of the two numbers. 2 and 6 are the two numbers. So I usually just start it with x equals the square root of the a times the b. So this one, a and b are 2 and 6. So we're going to put those underneath there. Just substitute 2 and 6 for a and b. So x equals the square root of 2 times 6. And right now I don't see any way of getting perfect squares out of here. I can't break 6 down. I mean, I guess I can. I could say 2 times 3. I could do that like they showed before, and now there's two 2's in there. And so that's one way you could do it. Or you could just multiply those and you'll see 12. And you can know, well, 12 is the same thing as saying 4 times 3. So 4 times 3, the square root of 4 times 3, the square root of 4, that means I can really see what that's going to equal. The square root of 4 is 2. So this is going to be 2 square root of 3 as a simplified radical. If I needed to get that into a decimal form, I could do that. I could just go ahead and just even go back from here to the square root of 12, and hit the square root button. And it's 3.5 if we go to one decimal place. So if we needed one decimal answer, we could also do it that way, 3.5 approximately. So go ahead and stop the video at this point and try number 4. 5 and 45 are the two numbers. Do the same thing here for number 4 and see if you can figure out what the geometric mean is. Okay, hopefully you got your answer here for number 4. Let's go ahead and just take a look and see how you did. So we're going to say that, basically we're going to multiply 5 times 45 there under the square root sign, and we could, on this one, we could multiply those together, or we could also see 45 has got 5 times 9 in it, so we could do it that way and do 5 times 9. And well, since there's two 5's here, the square root, that would be 25. Square root of 25 would actually be 5, and the square root of 9 is actually just 3. So we're really going to see it's just going to become 5 times 3 is our answer. And we know 5 times 3 is 15. So there's our answer for this one. Hopefully you got that answer. Now you may have done this. You may have multiplied 5 times 45 there and got 225. The square root of 225 is 15. So that's another way you could have done this and you got the same answer. So as long as you got 15, you did it right. Okay, here's our joke of the day. So this one says, 2 lawyers walking through the woods spotted a vicious-looking bear. The first lawyer immediately opened his briefcase, pulled out a pair of sneakers, and started putting them on. The second lawyer looked at him and said, "You're crazy. You'll never be able to outrun that bear." "I don't have to," the first lawyer replied. "I only have to outrun you." All right, so let's go on to finishing our lesson here. Almost done. So geometric mean altitude theorem and geometric mean leg theorem. So these are right there on page 255. So page 255, you can see these two. So basically we see our triangle looking kind of similar to what we saw before. There's our right triangle, our altitude again. And so what we're going to see on this one is for the geometric mean altitude theorem. So it's basically saying in a right triangle, the altitude, that would be the altitude here, is going to be from C to D. So from the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments, which you can see definitely it does, AD segment and the BD segment right there. So the length of the altitude is the geometric mean of the lengths of the two segments of the hypotenuse. So now remember the geometric mean would be like, this would be like your x here, so this would be like your x squared equals these two times each other. And that's what the geometric would be, or you could think of it as this altitude would be the square root of these two times each other. Okay, that would be our geometric mean again. And then the next one is about the legs. So this one was about the altitude here, this segment. Now the legs would be these two right here of our right triangle. This would be our hypotenuse from A to B. Well, A to C would be a leg, and B to C would also be a leg of this right triangle, of the bigger one. So in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments, which we saw already before, same thing as it says up here. But now the new part, the length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. So if we're finding, this leg right here, or this one here, it doesn't matter. First one says C to B right here, so that's the short one. So our short leg would be the geometric mean of the whole entire hypotenuse, and then this piece that's adjacent to our one on our triangle here. So we have our B squared, which would be this, and then the whole entire thing, and then the shorter one here. So the whole entire thing would be A to B, that's this one, and then the shorter one here, B to D, or D to B, that's the shorter one there. Again, we could take the square root of both sides, so it's just the square root of those two times each other. Same thing if we're looking for this one, A to C, that leg of this triangle, that's the long leg. So that would be the whole hypotenuse, and then this piece right here from A to D. So A to D, and then the A to B segment, those got to multiply each other. We could take the square root of that to get our longer leg here. Okay, I just want to be clear about this now. So if we're looking at this altitude theorem, we're looking for the altitude right there. We're going off of these two segments. So basically we have segment 1, segment 2, and so we're looking at seeing that the altitude I'll just say alt like that, is equal to the square root, because this is the geometric mean now again, of segment 1 times segment 2. I'll put seg 1 times seg 2. So that's how we're doing this altitude theorem. For the leg theorem, we are looking for something not the altitude. We're looking for a leg here. So we're looking for one of these legs here. So if I'm looking for, let's just say this one over here, which is this side, that's what I'm looking for from C to B. Okay, so I'm looking for that piece right there. So we could say, okay, x is equal to the square root of the hypotenuse, the whole entire hypotenuse. That's going to be the entire hypotenuse of the whole thing, because we have the altitude again splitting up our segment 1, segment 2. Okay, so that would be the altitude is going to be the splitting up the hypotenuse here. So we have to do the whole entire hypotenuse. So we can say hypotenuse, so it's the square root of the hypotenuse times basically the other leg. So on this little triangle that we have here now, so we have this little leg right here of the hypotenuse. So that's going to be like segment 2. If I said segment 1, segment 2 here, we're looking at hypotenuse times segment 2. So I'll put seg 2 on this one. And let's put y maybe up on this leg right here. So this leg over here from C to A, if I said, okay, that y is going to equal the hypotenuse again. So this is what we're looking for when we do the leg. It's the whole entire hypotenuse. So it's the hypotenuse times segment 1 this time, because that's the segment that's with this one on where y is. So we're looking at this kind of divides it up here. Divides the segment up, divides these two legs up as well. So this is going to be with segment 1. So I'll put seg 1 on that one. Alright, so hopefully that helps you a little bit. Let's go ahead and try some of these. Okay, so here's number 5, find the value of the variable. And so our variable here is the altitude. So that's going to be using the altitude theorem, the geometric altitude one. So it means x, we can just start off with x will equal. X is going to equal the square root. This is what we do for a geometric mean. We can just start off with x equals the square root of now these two times each other. Segment 1, segment 2. So 9 and 16 is segment 1 and segment 2. So 9 times 16. So we could multiply those. So here's what we could do. We could multiply them if we want to, but I already noticed 9 and 16 are both perfect square numbers. I can maybe break those apart into their own radicals. So square root of 9, square root of 16. So I can see that's just going to be 3 right there. And this is going to be 4. So we're just going to get 12 on that one. So we can just say x is going to equal 12. There's our answer for x. Come over to number 6. We're looking at y right here. Now you can see y is not an altitude. It's going to be a leg. So it's one of the legs here on this side. And so we want to look at y equals, I'll put on this side over here, y is equal to the square root of the entire hypotenuse of where this is going. So this is always connecting, the altitude is always connecting the hypotenuse of this big triangle. So that would be the 9 plus the 2. We got to add those two up. 9 plus 2 is 11. So it's going to be 11 times the other segment, or segment 1 in this case. So we have these two segments, segment 1, segment 2. So times this segment, which is on the same side as the y. So times 9. And so what we can see here, y is going to equal the square root of 9. We can think of this as the square root of 9 times the square root of 11. Square root of 9 being 3. So this actually is going to be 3 square root of 11. And if we needed to get this into actually a decimal form, we could do that. We could say approximately 9 times 11 is 99. And if I just do that on the calculator here, 99, hit the square root, that's approximately 9.9, just in one decimal place. So approximately 9.9 as well. But most likely that's going to be our answer right there that you probably have to put in on the computer. Number 7, so we're looking for the value of the variable. Now this time it's a little different. The value of the variable is this very long side here, which is the hypotenuse side of this triangle. And so you can see our altitude on this one makes this into a very tiny little triangle over here. And then you have this altitude, or this hypotenuse, really long here. So if we're looking for that, so what do we know so far? So we know a leg here. We know 49 is a leg and we know here's segment 1 of that one, and then segment 2 would be over here, but we have the whole entire hypotenuse. So we don't know the altitude. They didn't give us the altitude, so we're not going to be able to use that altitude theorem. We're going to use the leg theorem. So this time we got to remember, okay, how would we set this up? Well, we remember that it's going to be the leg here that we have. So our leg is just 49. So we'll just say the leg, okay, is equal to the square root of the hypotenuse, right, this is what I wrote down before, times segment 1. So what I don't know is I don't know the hypotenuse on this one. So we could also go back here and we could do it like this. We could say the leg squared is the same thing as the hypotenuse times segment 1. Remember, we can also have that being the same thing. We could start it here if we needed to, which on this case it might be better to do that since the one we're looking for is the hypotenuse. So if I start off with the leg that we have here, 49 is our leg, so that's going to be 49 squared is equal to the hypotenuse times the 7. What's 7 times t? So it'll just be 7t then right there. So if I try to think, okay, what's 49 squared? Well, we can do that on the calculator real quick. So 49 squared, that's going to be 2,401. So 2,401 is equal to 7t. And then just divide by 7. So we'll divide over here by 7. And our answer is going to be 343. So t is equal to 343. And there's it. Value of the variable. And our last one right here, number 8. So this time they do give us an altitude, so we're going to use the altitude theorem on this one. So again, we might want to see it as this, where we're going to see altitude, ALT, and this time maybe I'll do it with the altitude squared is equal to the segment 1 times segment 2. You know, instead of putting the square root around this, let's go back and start with the altitude squared. So our altitude we know is 6. So it's going to be 6 squared is equal to segment 1 and then times segment 2. So we could say, well, just these two times each other, 3 is going to be multiplying a plus 4. And there's a small little equation. This is obviously 36 from 6 squared. Distribute here, so we get 3a plus 12. And then we just subtract our 12 from both sides. And so that's going to give us 24 is equal to a 3a. And so when we solve, we get dividing by 3, a equals 8. So there's our value of the variable on that one. Okay, so we're almost done. We have one more I do want to talk about, and this one's going to be on the quiz that we're going to do right after this lesson. So once you finish this lesson, you should be working on your assignment for the lesson, and then we'll be taking a quiz. And this next problem I want to show you is on that quiz. So let's take a look at this one here. So this diagram is a guy standing in a gymnasium, and it says here to find the cost of installing a rock wall in your school gymnasium, you need to find the height of the gym wall. You use a cardboard square to line up the top and bottom of the gym wall. Your friend measures the vertical distance from the ground to your eye and the horizontal distance from you to the gym wall. Approximate the height of the gym wall. Okay, so you're standing here with this cardboard square, and you're kind of doing it a bit diagonal here, so you're holding it this way, and you have your eye level, so it's basically right at eye level here. And so so your friend, he's going to measure probably with a tape measure the square, the end of the square all the way to the wall. That was 8.5 feet. And then from the bottom of the wall up to where the eye level is, up to where your eye level is, that's 5 feet. And so those are the two numbers you need to have here on this one. And so what that means is that we're going to see the top of the wall here down to where this square would be at is going to create a similar triangle. So we can have the same idea using the geometric mean. So here's our altitude then. This would be our altitude, this 8.5. And here's segment 1, segment 2 of that triangle. And so basically that's what we're going to be doing is just using that geometric mean. So 8.5 squared is equal to W times the 5, which is just 5W. 8.5 squared is 72.25. Just divide by 5 at this point, and so W equals 14.45. Now that's what W is from here to here. It says approximate the height of the gym wall. So that means that the whole wall is actually the 14.45 plus the 5. So you have to actually add that in for your answer. So you can see our answer there is 19.45 feet. So that one's going to be on the quiz that we're going to see. We're going to see one similar to this on the quiz. So, all right, go on to 9.3's assignment now. Finish that up, and then you'll be ready for that quiz. And I'll see you back in class.